This is problem number 1 for assessment number 6. In the problem they say use the vertex formula to find the vertex of the following function. And then part B, find the intervals where f is increasing and where f is decreasing. So remember, vertex formula would be f of x equals a x minus h squared plus k. So with vertex formula, what we're really looking to do is we're looking to change your quadratic into a quadratic that has a perfect square factorization in it. So in order to do that, the first thing we need to do is try and get this leading coefficient to be 1. I prefer to do that to start, so I think that we're going to divide by 3 on each spot in this function so that this makes it easier to do completing the square. So this is f of x over 3 equals x squared minus 8x plus 46 over 3. And now I'm going to complete the square. So when we complete the square, the first thing we do is we take the middle term, which our middle term is negative 8, we divide it by 2, and then we square it. So negative 8 divided by 2 squared, that's negative 4 squared, which is 16. So that's what I'm going to add to the right side, and I'm also going to subtract it so I don't actually change the equation. So I'm going to say f of x over 3 equals x squared minus 8x plus 16 plus 46 over 3 minus 16. So when I add the 16 in, because I took the middle term and divided it by 2 to give me negative 4, and I squared it to get the 16, I know that this trinomial is going to factor into a perfect square. The factors of 16 that add to negative 8, well, that's negative 4 and negative 4. So I'm going to have x minus 4, x minus 4, and then I need to just combine these two constants together. So this is going to be plus 46 over 3. If I multiply this by 3 over 3, this will give us, let's see, 30, 48, so minus 48 over 3. F of x over 3 equals this. This will give you x minus 4 squared, so I have f of x over 3 equals x minus 4, because there's 2 of them being multiplied, that's x minus 4 squared. When I combine those, I get minus 2/3. Last step is just to multiply the entire equation back by the 3. So I divided it out to begin with. At the end, I'm just going to multiply it back in after I've done my manipulations. So I multiply by 3, and when I do that, it cancels here. 3 goes to the front of the x minus 4 squared and is now the leading coefficient again. And then when I take 3, this is the thing that most people forget, take 3 times the negative 2/3, and when you multiply that, that's going to give you negative 6 over 3, which would be negative 2. I just cancel the denominator. So this is part A, at least a portion of it. They wanted us to put it in vertex form. Now they want us to state the vertex. So the vertex, remember the vertex is h comma k, which in our case is, well, h would be the 4, right? Because remember it's negative h, so we do the opposite sign, so that's 4 comma negative 2. That's our vertex. So these are the solutions for part A. Now for part B, they want us to state when is this thing increasing and when is it decreasing. Well, first of all, I have a positive leading coefficient, meaning I have an upward facing parabola. So we can say upward facing. Because it's an upward facing parabola, we know that the left side of the parabola is decreasing and the right side is increasing. And the vertex is the spot where that splits. Essentially, that's the spot where the slope is 0 and it switches from being a negative slope to a positive slope. So the vertex occurs at 4, -2, so that means our interval for decreasing, so we're going to say decreasing, it's going to be decreasing from -infinity to 4, and it's going to be increasing from 4 to infinity. And we can tell that just by looking at the leading coefficient and then the vertex.